Now let us understand the basic representation of number in decimal. How we can represent numbers as decimal numbers as 0 and 1. So suppose we got a number binary representation. Now for any number, say 12, the binary representation will be 0 plus 1, 0 0 1 1 0 0 0 0. So this is the representation of 12 in a 4-bit decimal number. Now here every bit represents 2 to power 0. Now this represents 0 into 2 to power 0, so which comes out to be 0. This is 0 into 2 to power 1, and similarly this is 1 into 2 to power 2, which comes out to be 4, and this comes out to be 1 into 2 to power 3, which is 8. So as we know, 12 equals 4 plus 8. So I got this representation for 12. So this is how we represent numbers in decimal, by dividing the number and accordingly getting the remainder. So accordingly we can put down ones where we want the value to be and zeros where we do not want the value to be. Accordingly we can see for any other number, say 22. So we can have 22 as 4 plus 16 plus 2. So this is how we can break down any number, so that we can put down bits, because every bit is a multiple of 2. So we need to break down the number into multiples of 2. So I can have 0, then this is 2, then this is 4. Sorry, I'll just rub this. So this is 4, I need 4. I don't need 8, but I need 16. I don't need 32, I don't need 64, and don't need 128. So this is how we can represent 22. This represents 2, this represents 4, and this represents 16. So adding all the numbers gives us equivalent of 22. So this is how we represent numbers in decimal. Now let's see what we mean by ones complement. Now for a negative of a number, we represent a number as a ones complement. So ones complement means changing every bit to the reverse. For 0 we write 1, for 1 we write 0, so this number is the ones complement for this number. Now accordingly we can see what we mean by twos complement. Now twos complement is adding 1 to the ones complement. So 1 and 1 means 10. So 0 comes here, 1 carry over, 1 plus 0 comes 1, and rest bits come as such. So this is the twos representation for the number. Now why we have two complements for a number, ones complement and twos complement. Now the problem for ones complement is, suppose we take 0 as a number, suppose I say plus 0, which is all zeros. So let's take for 4 bits 0 0 0 and 0. Now minus 0 comes to be, which is the ones complement, 1 1 1 and 1. So for ones complement there is a different representation for minus 0 and plus 0, where mathematically minus 0 is equal to plus 0, whereas for ones complement these two are different. Now let us calculate what is minus 0 as per twos complement. Now let us add 1 to this. So this is 1 plus 1 10, 1 plus 1 10, 1 plus 1 10, 1 plus 1 10, and 1 is carry over thrown off. So for twos complement the minus 0 representation comes equal to plus 0. So this is why we mostly use 2's complement rather than 1's complement for all calculations to be followed in calculators and all. Now this extreme left bit is important for any binary representation of numbers in languages, because this stands for sign in case the variable is signed, and this represents value in case the variable is unsigned. So in our next we'll see difference between signed and unsigned, and accordingly we'll see how Java variables are represented. So this is a brief small lecture regarding how to represent a value in decimal in bits, what is 1's complement, and how exactly do we calculate the 2's complement for a number, and why 2's complement is followed rather than 1's complement, the difference being the representation of 0 under minus and plus is different in 1's complement, whereas comes out to be same in 2's complement.